So Year 12s, while I'm over at the State Netball and Hockey Centre coaching netball, you're going to be looking at determining normal probabilities. So as we've seen so far, if we take a normal distribution, say this one here, and we look at the probabilities, say that this distribution is the Z distribution, I think all we basically know so far is that between -1 and 1, and +1, this area here is roughly, you might recall, 0.68 and a bit more. Between 2 standard deviations it was 0.95, and 3 standard deviations left and right of the mean it was 0.997 ... Okay, so that's really what we know so far. Now what the CAS has got for us is it's got the normal distribution defined. So imagine on the calculator we defined the normal distribution function and then used it. Well, similarly we don't have to define it. It's got it sort of inbuilt, if you will. So the feature that we generally use is this one here called norm CDF. Okay, and basically all it will do is help us find probabilities. So say for argument's sake I'm finding the probability that the random variable is less than 20 if the normal distribution has a mean of 20 and a standard deviation of 3. So let's define that random variable. X is normally distributed. Recall that we put the mean first, which is 20, and in our definition we write the variance. Okay, so this is going to be 9. Okay, now what we want is the probability that the random variable I just defined is less than 20, x less than 20. Now recall that that can also be written like that, and it doesn't matter either way. Alright, so we're going to get the probability. Now if you want to know kind of pictorially what we're doing, okay, that this is a normal distribution curve, and that's a terrible one. Let's try that one more time. Okay, that's not much better, but it'll do. And what we've got is a mean of 20 and a standard deviation of 3. So here's 20 over here. And we're basically asking it, what is the area under the curve for values less than 20? So that's this part here. Okay, and we can see here, I've done it earlier, norm CDF, and I'm going to do it again just so you can see how it's done. So add calculator, and according to my notes it's menu, 5 for probability, 5 for distributions, and we want norm CDF, that one there. Okay, so the lower bound basically says where do you want to start, and we know that the normal distribution curve is defined for values of x from -infinity to +infinity. So we're going to start at -infinity, and where we're going to stop is 20. Okay, that's the upper bound. So basically we're integrating on a transformed Z distribution between -infinity and 20. We plug in the mean, which was 20, and we've got to plug in the standard deviation, which was 3. And we hit OK on that, and there we go. It tells us what we already know, which is that below the mean it's 0.5. Okay, or 50% of the values fall below the mean. So we're basically going to use this now to answer a whole heap of questions. Alright, so what do we got here? The distribution of Navy officers is found to be normally distributed, so I'm presuming that that's the height of Navy officers with a mean of 175 and a standard deviation of 5. So I think the first thing we should do is define our random variable as normally distributed with a mean of 175 and a variance of 25. Okay, so what we want is a height less than 175 centimeters. Okay, so that's the probability that the random variable is less than 175. Okay, and just like the last question, that if the mean is 175, then the probability that it's less than the mean is also going to be 0.5. But let's do that, and here it is again. So norm CDF. Lower bound is -infinity. The upper bound, we're going all the way up to 175 in this case, with a mean of 175 and a standard deviation of 5. All right, and same thing is confirmed as the previous distribution, so 0.5. All right, B, a height between 170 and 180. So probability that the random variable falls between 170 and 180. And I certainly know, according to this rule here, that this is one standard deviation to the left and the right of the mean. So again, if I was to draw this, I kind of draw one of these lines here, put the mean down, 180, 185, and 190. Alright, and then what I do is a little line there, and then just try to cover the 3 standard deviations. So we're asking for the probability that it falls between this value here and this value here. And I know that that's going to be 0.68, okay? And what I'm going to do is just pump that into the calculator. So I'm going to do a norm CDF. Now I'm just going to edit the old one. So the first one is the lower bound, so that's going to be 170, and the upper bound is 180 in this case, and we've got 0.682 dot dot dot. All right, C, so that's going to be 2 standard deviations to the left and the right of the mean, so that's going to be probability between 165, just to be different for this one, 185 equals, so this one should be 0.95. So 0.954 dot dot dot. Okay, a height greater than 190. So that is more than 3 standard deviations above the mean. Now we know that 0.3% of values fall 3 standard deviations either above or below the mean. So above that is going to be 0.15, and then it's a percentage, so to turn the probability we're going to go 1, 2. So the answer to this one should be 0.0015. Okay, so the next one, but I'm going to do it on the calculator as well. So probability that the random variable is greater than 190, so it's going to be a very small probability. This is the chance of someone falling 3 standard deviations above the mean, yeah, so 190 is the lower bound, and the upper bound is going to be positive infinity, which is there. Okay, and there it is. Okay, so you can see here that these approximations are not fantastic. Okay, well, they're pretty close. I shouldn't say not fantastic, but these give better approximations if we do it with the CAS. Okay, a height between 165 and 180. So here's 165 and here's 180. So that's going to be 68, and 95 remove 68 is going to be, what is that, 270, oh my god, 27. So this is going to be 13.5 and 68. Right, so what we're going to get here is roughly a probability of 68, 78, 81, 0.81 or something like that. All right, so let's do that. Probability that it's between 165 less than or equal to x less than 180. So I'm just flip-flopping around with the equal signs or greater than any equal signs, just to show you that it doesn't really matter. So the lower bound is 165, upper bound, what was it, 180. Yeah, so 0.8185 dot dot dot. Okay, so you really don't want to use this rule here. That's more for general maths. For maths methods, we're going to get a more precise value, okay, or easily a value to 4 decimal places, not these ones which are to 2 decimal places or 3 decimal places. Alright, so let's try another one. So we're on the Z distribution. So a reminder that Z is normally distributed with a mean of 0 and a variance of 1. Okay, so the chance of it falling between there. Alright, so what we'll do is we'll say probability that it is this equals. So again, we're just going to use CDF to do this. We're going from -1 to 2.5. So pictorially you could get a pretty good approximation of this. Mean of 0, whoopsie, standard deviation of 1, and 0.835 ... Alright, probability that Z is greater than 1. I probably know this one, so that's going to be, here's 1, 1. So that's going to be all of this part here above 1. So that's going to be 100 remove 68. So that's this part here, equals 32. So it's going to be 16. So the answer to this, probability that Z is greater than 1, should be 0.16 something or the other. Let's find out what it is. So from 1, I think, yeah, to positive infinity. With a mean of 0 and a standard deviation of 1. Yeah, so pretty close. 0.1586 ... Alright, and what do we got next? Okay, so find the probability that the random variable is less than 32 if it's normally distributed with a mean of 28 and sigma value of this. So let's just define our random variable. Normally distributed 28, 1.7 squared. Okay, so again, I'm just trying to reinforce that this is the way we define the normal distribution. So again, that's just a classic CDF question. So we're going to go from negative infinity all the way up to 32, mean 28, standard deviation 1.7. Alright, and this should be pretty high, okay, because you can see that the mean is 28, standard deviation roughly 2, so this is more than 2 standard deviations above the mean, so we're going to be in 0.9, very high probability. So A equals, yeah, very high, 0.9906 ... Okay, B, above that value if we're on the standard normal distribution, or the Z. So let's get an old Z, and we want it from 0.56 up to positive infinity, I think. Alright, so again, we're half a standard deviation above the mean, so it's going to be a little bit less than 0.5. Okay, so my guess is maybe 0.4 or something like that. Okay, not the world's best guess, but not awful at the same time. 2877 ... Okay, find the probability that the random variable is above 14 if the mean is 12 and the standard deviation is 3. Okay, so let's just get this one here. Okay, so we're going from 14 to positive infinity. What's 12, isn't it? And yeah, just be careful here. Don't type in 9, type in 3. So again, let's just have a bit of a guess. The mean is 12, and the standard deviation is 3. So this is a bit above 1 standard deviation. So the answer is going to be 32, 16. Let's go 0.15 or 14, I think. Let's see. Ooh, 0.25. Okay. Why did I get that so wrong? Because 14 is above that. Oh yeah, that makes sense. Okay, so 0.2524 ... Okay, so just check the rounding. I think this is the final question here. So D, we're back on the Z distribution again. We want it between a little bit less than 1 standard deviation up to there. So let's check this one out. So I'm going to go back to the calc, grab another Z. Lower bound, negative 1.25. Upper is negative 0.12. Alright, so this should be around about, well, I don't know, 0.32 or something. 0.3465 ... Alright, so yeah, so this exercise is basically just playing with this CDF feature and using it to just grab some probabilities from normal distributions. So good luck with that.